Good afternoon, everyone. I welcome you all for day three of our FDP. And on day two, I started a research project. That's what you are seeing currently. A research paper which is titled Improved Brain Tumor Classification Through DenseNet 1 to 1 Based Transfer Learning. And we were exploring this research, what authors did. It's a latest research paper, which was published in Discover Oncology. In this research paper, I read in front of you the abstract, and as per our discussion for day number one, that we do first talk about our topic, like what is brain tumor, how it is affecting. Then we need to tell the limitations of existing work, and then we need to switch towards our contribution in the research. In this, we will mention the algorithm, the technique, the data set which we have used, and what scores we have achieved, and how better we are in comparison to the others. And this is how we are going to conclude our research. Okay. So, like in this way, after abstract introduction, discussion went on, and again one para for each, one para for brain tumor, one para for computer vision, para for the algorithms, and then one para for what we did. And then later on, the last para we are writing that this paper is being divided into these sections. Section number 2 is for literature review, section number 3 is for methodology, section number 4 is for result analysis, section number 5 is for conclusion and the future work. Okay. In literature review, at least 20-30 papers as per the length, how much required, where you want to submit the paper. 8 pages, ten pages. Okay. Now, also we need to check it's one column or two column submission. What's the requirement? Accordingly, we will adjust the content. Okay. So, literature review will pick up the papers here also. They have mentioned, and for the literature review, how we organize the papers in literature. In literature, the organization of paper, that's what we want to discuss. like does it based upon the techniques, like should I start with ml algorithms, then come to the dl algorithms, then come to the hybrid algorithms, or any latest or new or a different kind of algorithm, or it should be year wise you are planning that we will first start with 2025 papers, then 2024 papers, then 2023 papers. Because when you are writing the paper, it has just been clear that you are going to add the latest papers. We are not interested in 2015 paper, 2016 paper. No, because what latest, what recent advancement has been done in the research, we need to incorporate in the review. Okay. So either you are going with the techniques side, or either you are going on the year side. What will be your contribution here, how you are going to take it? Also, are you going to mix up the paragraphs, or are you going to write the separate paragraph for each and every citation? Separate para, separate for each citation, or you are going to mix up, and mixing depends upon the techniques. I think that will be good. Or like you are looking forward to focus on ear and techniques both, in this is the way you are going to write it. Okay. Literature review, because it has been asked by the guide that whenever an external comes, whenever a review happens, whenever you are going to give the presentation, the reviewer, the external, the questions are being asked the initial chapters more. That is what they say. From the initial chapters, okay, okay, wait. I haven't shared my entire screen, so you are just listening to this only. Okay, now I'm sharing the entire screen. Now, here it is. Because I was explaining on the template. I hope now my entire screen will be visible to everyone. Well, this is what I was explaining on the sheet, on the template. This is what I was explaining. And I hope it's clear to everyone. Like this sheet is visible to everyone. Okay.
Yes, sir.
All right, fine. So I was explaining here, the paper was in visible. Anyways, so it has been asked that in the initial chapters, from the initial chapters, the question comes, and then later on, you are having methodology, etc., etc. But the initial chapters keeps importance. Literature review, and when we are preparing our thesis or dissertation, or then in that case it has been asked that at least 30 to 40 pages should be there for the literature review. So collecting the latest papers and assembling them and making all the notes from them, it's a challenge. Obviously it's a challenge. Well, I think in the previous discussion I told that you also know, when we pick up a paper, when you pick up a paper, well, if you want to be in a quick mode, what is present in the paper, then we look for abstract and the conclusion part. What is there in the abstract and conclusion? All right, fine. And I don't bother that you are using the an AI tool, because that is present for our assistance, that is present for our help. So I don't bother that you are going to use an AI tool. So one of the easiest way could be that you kindly collect the papers, 20-30 papers, latest research papers of your interest, your choice. Kindly collect those research papers. Okay, where your title, your topic is mentioned, your techniques are being mentioned. Kindly collect them. Okay, and obviously, year wise you can keep it. Okay, so organization will be like this only. Year 2026, this folder, then year 2025, this folder, then 2024 folder, then 2023 folder. And keep the papers in folder wise. Okay, once you got these papers in the folders, now you pick up a paper, take its abstract and the conclusion, and okay, right now let's consider we are using an AI tool. Okay, the research is also being changed. Okay, previously the kind of research which was being happened, or like, we take more time in reading. Okay, we take more time in sorting. Fine, but now research technique should also be changed according to the time. Okay, so let's say currently I am interested in taking help of a AI tool. So what I'll do, I will copy the abstract and conclusion of a paper in the AI tool, and I will give a prompt. I will give a command to it that kindly summarize. Kindly summarize. Okay. Kindly summarize in few words, few simple words, that what authors did. What authors did. Okay. I need a summary, simple summary, 4 lines, 3 lines summary. I need what the authors did. Okay. Then you will get some output. Okay, like this way. You are going to get the output. As on day number two, the query came, sir, we made a paper and then we gave for the plagiarism check. Initially the plagiarism was less, but when we updated that content and again gave for the plagiarism check, then sir, it happened to be less, plagiarism increased. So there is a fight, there is a competition between you and the plagiarism. Don't worry, you will be in a competition right now. And AI write exactly what how you write. Now AI is also getting smarter. It's getting smarter. You will, what you write, AI also write in the same way. Okay, so it will be challenge for reviewers also, it will be challenge for the publishers also. Okay, if they totally depend upon the turnitin, that whatever turnitin is saying, that is correct. See, this is also a tool. This is also a tool. Okay, if the turnitin saying that your plagiarism report is AI content is more than 10% or it is more than 15%, we are not going to accept your paper. See, if you check the older documents, if you check the older documents before AI, and if you give to the check, plague check, then also it will show the plagiarism. Then also it will show the plagiarism. The point is AI tools are trained on these data sets only. AI tools are trained on these data sets only. So what's supposed to be a solution? What is a solution for it? Because right now in research, we previously we used to have only the plague general plague issue. Now we are having an AI content issue also, and AI is already trained on such kind of data. Okay, fine, and it's getting much and more better how to write. Okay, so like I personally believe not entirely depend upon the turnitin. Okay, we try our level best to write from our side. Okay, so let's say if we have taken the content from the AI did the summarization. We don't copy exactly. We don't do that. We also write in our words na, in this research or authors, like the authors in their work, we give the citation. Okay, authors in their work used the technique, etc. We write from our side. This is technique they have used, this much accuracy they have achieved, this is supposed to be a data set they have applied, they have mentioned such limitations. Okay, so what authors did, what results they have achieved, what are the shortcomings, what challenges they draw, like in terms of future work. So one line, two line, three line, four line literature for a paper. Okay, if you took any help like AI, as I'm saying that we are not going to entirely as it is copy paste in our, no, we are not going to do that, but at least we get a summary. We At least we get a summary. Okay, with the summary help, you can refine from your side. Now again, it may happen that you have written from your side, you take some help, okay, with some of the words. Okay, again one thing, there are some words like which I always see, leverages. Okay, leverages, such kind of words na are used by AI more. So try to be simple, use the simple words. Okay, efficacy. One more word. Efficacy. We write efficiency. AI write efficacy. Don't use those words. So, like, we should be aware. Leverages, that it means useful. Efficacy, efficiency. All right. Also, I'm letting you know that don't write sentences which are having 15, 20 words in it. No, not at all. Don't write 15, 20 words. No, not justified. 15, 20 words. You have to break it. You have to break it. Make simple sentences. Simple sentences. These are the ways by the help of which we can be away from AI plagiarism. Simple sentences. Break them. Eight. 8 10 words, 8 10 words max in a sentence has been there, fine. That's what should be done. All right. So in a literature review, I need a suggestion from you because last day also madam gave some suggestion that what happened exactly. So like what's the practical scenario? What do you feel related to literature review? Let's have a discussion. Yes, madam, or any other faculty. I want to get some feedback from your side. Literature review. Here in the template I mentioned that how you are going to place the literature review. Technique based, year based, mix up, paragraph, or in a single para you are going to mix up all the authors what they did. Because if I talk about this paper, how they are working, see, if in a para, see in the para, recent work has further advanced transfer learning in brain tumor imaging, ETAL improved. Okay, we are adding the main author and then rest of the authors. Improved the unit and made next model for African patients. This is the citation. Okay, exactly that's what I said. Author with their technique and the scores, what they achieved. Technique score. Okay. If there are limitations you want to include, you can. And future work also, what they suggested can be done ahead. Similarly, again the author introduce HTCNN technique that combine with CNN, which work well on the different types of tumors, perform better than the past winners on the bread's competition. So any competition, any specific data set mentioned, right? Okay. Then what next here? Brain tumor classification is in transfer learning few years. For an example, this paper, efficient net was used 98% accuracy as compared to denser net. 14 times more parameters. Okay. So straightforward. Technique result. Technique result. But how's the assemblance? How's the assemblance? How they wrote this entire para? What's the target? What they thought? Are they specified about the technique? Are they specified about the latest research or the year wise scores, data set? What exactly they are doing? If I talk about the above paragraph, here is support vector machine. That is a traditional machine learning algorithm. And what they are talking in the upcoming para, they are talking about the transfer learning algorithms, latest ones. But next, again, I can see word support vector machine, random forest. These are traditional machine learning algorithms. So in their review, it happened that traditional machine learning algorithms also came, transfer learning algorithms also came. Okay, then you can see ahead CNN based, CNN, KNN ML, mostly CNN based algorithms are there, mostly. Then they are talking late 2021. What happened? Okay, late 2021, what happened? VGG19. Okay, this is the data set. Brad's 2015, 16, 17, 18. Here is the data set. LSTM again is an algorithm. So, entire literature review is based upon algorithms scores. Algorithms and the scores. All right. So, how we can plan? How we can plan our literature review? How we can plan our literature review? Now, it's a question. Should we start from latest like 2025 26 to 2022 or 23, or we should start from 2022 23 and end with 2025 2026? Now, here is my question to you all. What's your suggestion here? How we start a literature review? From latest years to the old, mentioning the techniques and the data set and the accuracy achieved over like this way, or just revert the process. Yes, what's your suggestion here? What do you think? From latest to oldest or oldest to latest? What do you think here? Well, you have made the papers, now you submitted the papers. Any suggestion from your side? Yes. And
Latest will be better, no, sir?
yes, yes, ma'am. Yes, ma'am.
Latest will be better, no?
Okay, latest will be better. That means obviously we are considering 4 years max, 3 to 4 years papers. Okay, that's what this is the range. This is the window we are considering. So accordingly, if madam, that's what your suggestion says. Latest will be better. Latest will be better. That's what you are saying. If someone reads the paper, if someone reads your literature review, so he should get an idea that okay, this is what happening currently. This is what happened previously. Currently, this is what happening. These algorithms on this data set, this much scores has been applied by the authors. Okay. So latest ones. We will pick up 2025 or 2026 papers. And according to the data set, let's say brain tumor data set, what is the technique used by the authors? How much are those scores achieved by them? What are the limitations? Let's make a table. Let's make a table. All right. It doesn't matter. You can again take a AI help. I don't bother about it. You can take, but because you are going to write in your words only. I'm not saying that you are going to entirely copy and paste. So if in case you can make a table from your side, first make a table. Then we can write in our words. That is what we can do. First, make a table. This was the paper, year wise. This was the paper. Here are the authors, paper, year. 2026. These are the authors. This is the data set taken. These are the techniques used, and these are the scores they have achieved, and these are the limitations they have listed. All right. Now we can write in words. Authors name of the authors, or either you can write in a square brackets according to whatever be the demand, general, conference, okay, IEEE, scopus, SCI, okay, whether they are accepting ETL or they are accepting the square brackets. Okay, so let's consider. Okay, authors, whether they discussed, whether they build, whether what exactly they did. For example, if I check this paper, okay, what they have written on: employees grab cut for segmentation and VGG19 for feature extraction in their approach. So what exactly author did? Have they built any model, or they discussed, they applied, they employed? What exactly the author did? Okay, and like not every time we need to write authors did this thing, this thing in another para. Author did this thing, another para. Author did this thing. No, 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 not at all, not at all. Sometimes we need to mix up. In a similar research, authors used these technique and achieved this much score on that data set. Later on, it has been further improved by the authors using this technique to perform classification segmentation, got these scores. However, there are some you have to. That is why I said okay, literature review will take a bit time. Okay, once your collection is done, year wise collection is done, you are picking each and every year wise data, you are using assistant. Okay, AI assistant is fine, not an issue. Take consider this AI assistant. Okay, you are taking it as an assistant with you, and you are summarizing the abstract and the conclusion part. You are making a table at the end. You are having all abstract and conclusion for all the papers. Convert them into a final table. Final table. Now it's your turn to write with your words. I got a table in hand. I got a table in. Let's say I do have a table in hand. Let's say this is the table. This is a table in my hand. Okay, fine. So here are the authors mentioned: watershed, feature extraction, SVM, MRI images, segmentation, classification. If I keep this thing, Control C, write it here. Control V. Okay. Okay. Authors, authors in their research used MRI images for brain tumor classification and segmentation. They applied watershed algorithm algorithm with feature feature extraction and SVM for classification. Okay. By this technique, techniques, by these techniques, it improved the boundary pixel detection. It improved the boundary pixel detection based on marker based watershed watershed based on water watershed watershed and she square feature selection. All right, I haven't I am writing from my side only. I have written three lines, three para. Three means three lines, one para. I have written. I can make further more paras for different papers. So this is what I did. Now read it again. Authors. Okay. Khan ETAL. Khan ETAL. In their research used MRI images for brain tumor classification and segmentation. They applied watershed algorithm with feature extraction and SVM model for classification. By these techniques, by these techniques, they demonstrated that they demonstrated that it improved the boundary pixel detection in images, in MRI images based on watershed and she square feature selection. Okay, either you can break. By these techniques, they demonstrated, or by these techniques, they showed, or whatever I've written, they demonstrated that it improved boundary pixel detection in MRI images. Full stop. Or rather, you can break it because I said we're not going to make the huge sentences. By these techniques, they demonstrated that it improved the boundary pixel detection in MRI images. So, they applied watershed algorithm, which feature extraction, okay, already included, remove this line. If any score was mentioned in the table, we will incorporate the score also. It improved the boundary pixel condition MRI images. The final scores for classification was 98%. Score for classification was 98%, or we'll write the final scores or the accuracy, whatever you want to write, you can. The accuracy for classification was 98%. Done. Now, again, it's up to you. Any inputs from your side? How much I struggled, how much I struggled. Like there was a when we have started the FDP partner, there was a we want to make a paper, and like paper we don't want that much time to be invested. We are struggling now. What I did, I have a table where key points, and I have written in front of you. I am writing. I am not taking anyone's help here. In a very simple wordings, I am writing my one literature I have covered in these 4 lines. Now, any input from your side? I want to know. Yes. Anything? Anything? Any inputs from your side? I want to know. Similarly, you can pick up one more table and write 3 to 4 lines. So if you are available with 30 40 papers, I guess in a 2 day or max 2 day 3 day, you can wind up your literature review, isn't it, or not? Well, make this communication two-way. Expect some inputs from your side also. Yes, dear all faculty members, any input from your side, any suggestion? See, this is how simply I suggest we can go. Yes, any suggestion? How you make literature? Like, is this helpful? Is this helpful?
Sir, sir, is there any standard that these many papers should be taken, or it can
Mhm.
be as per the problem?
Okay, any standard these papers should be taken?
Hmm.
Well, madam,
Number of papers.
standards of the paper, like are you talking about IEEE or SCI or Scopus or any other kind of journal? That's what you're talking.
No, no, the number of papers. Is it required to be
Madam, for good one,
some
I expect at least 30 40 should be there as a review. This is what I expect.
30, 40?
This much paper should be there, madam, at least in your hand. For 3 to 4 years
Okay.
compilation, 30 40 papers should have to be there in your hand. And madam, and this table should be made. Comparative table for your topic should be made. Okay. And consider year also, year wise. Starting from the latest, then end. Yes, sir, please. Yes, any more query, please let me know. Any more queries, please let me know. And it's not a big deal to collect the papers. We can collect the papers. We can organize the papers, download and put it into the folder. I told you can use an AI tool, not an issue. Okay, and you can create a tables also with that. And once your table is finished, now it's your opportunity to write with your hand as per your. Here, no AI tool is needed. Okay, don't try AI tool here. No, I'm not suggesting any AI tool here. You got what is present in a paper, write with your own words. Okay, try to make it more informative. Okay, this is the way like we can write the literatures. Okay, then as per the demand, as per the requirement of the general, we can later edit. Okay, we can later edit. You can pick this thing on the overleaf, because we will be talking about the overleaf also. We'll be doing the demonstration on overleaf also. Okay, we can pick up this thing into early. If any of the English or something statements are, or the wordings are not being correct, then grammar vocabulary can be updated, can be corrected, not an issue. Take it on the overleaf. All right. Don't again. Suggest don't copy if like any kind of plagiarism is coming. Don't copy and change and paste it to any of the website and then again rephrasing it and again copying paste it. We are not going to uh, end the flow of the paper. Flow of the paper should not be ended. And one thing also I want to suggest you, once your table is there, so hardly 2 to 3 days. Okay, you should. It's and while writing now, our brain should be according to what we are doing. There should be thought process. Then only there will be a flow. Okay. Now I am also not saying that, and taking printouts is also important. Whatever you have written, take the printout. Take the printout. Okay. Underline where you feel that there are the issues. Underline. Okay. Fine. Do this thing. Do this part. Underline. You have to write some things in the copies also. All should be done. Okay. So literature review, as we are seeing here, the entire literature review, why this paper was published. If you can see the literature, everywhere the authors have mentioned algorithms. Every paper algorithm they have mentioned. If you see ResNet, GoogleNet, ANN, CNN, 89%, 97%, everywhere the authors mentioned that which technique used, how much accuracy achieved. Okay, clear cut. What data set used? Okay, and see, this is detailed literature review. How many pages and how many references they took? They started from the page number. If I say literature, the page number is here. It's four, four, five, six, six. Also, then 7 also they are using to write the literature review. 7, 3 pages, 4, 5, 6, 4 pages they have used. And how many citations they have used? 40. Citation mentioned here is 40. And I told in the starting also, again the question asked, sir, how many citations? 30 to 40. 30 to 40 citations should be there. Then only it will feel like you have read some papers in order to do your research. All right, then only. After then, whatever be the technique used, that day number two also we have discussed. Okay, on my implementation, this was the implementation which I shown on that day. Okay, and well, you are understanding, though it was difficult, it was tough because I took the images data set in front of you. The paper was also based upon this data set only, so I implemented from my side over this data set only. Okay, I explained you till the CNN part, convolution neural network. Till here, I explained you on that day that here are the plots and here is the confusion matrix. Here is the classification report. I am getting 87% accuracy I have achieved. Now the question is, sir, we need to use these plots in our paper. These all training plots and all. So how you make these plots, like how you make these plots, how you put your plots like in results, for example, currently you are seeing confusion matrix. How you are going to draw it? How you are going to draw it in your research paper? These plots, training plots, how you are going to draw it? Yes. What's the technique you do to make these plots? Currently they are saying, are you going to take the screenshot? We are going to take the screenshot. Okay, and then we are going to put it something like that. Okay, fine. Let me tell you some easy ways. Some easy ways what I do from my side. Well, I can download this code. Okay, I can download this code. Fine. After downloading this code, this will be in Python file. IPynb. This is in Python file. Let me tell you what can be performed by this Python or over this Python file. Let me help you with some AI tools also. Okay. All right. Just a second. So what I did is I have downloaded that my code, entire code. Okay, done. I hope now my screen is visible to everyone. I've downloaded that code, this one. Now what I'm going to do is you can there is one website which can convert IPYNB into doc. IPYNB to doc. This one, Vertopal. This is a website which can convert your Python files into doc files. Okay, so let me click on this. All right, let me click on this, and my file is brain tumor detection FDP code. Okay, so let me pick up this. Let me pick up this. Okay, let me pick up this from the downloads. Okay, brain tumor, brain tumor, tumor. Okay, brain tumor. Okay, let's say here it's brain tumor FDP. All right, brain tumor FDP code. Let me check here. Here it is. Brain tumor FDP code. So I will convert this code into doc file. Continue. Convert. So what will happen by converting this code into doc file? I will get the images. I will get the plots. Let me show you. Once it converts, then I will show you. Okay, because Python permits you to create all kinds of plots, which you can use in your research papers. Okay, got it. So it's converting into doc file, and we will take the necessary plots. Here it is, download. Okay, and let me pick up this one. Now I will show you the code which is converted into doc file. Here it is, enable editing. Here it is. This is my entire code which is in doc file, and you can see this distribution of tumors, count plot and the pie plot. See again, it's your choice of interest, sir. We want to because there is one section in the research paper. There is one section in the research paper where you need to mention data details. No, that's what you need to mention, data set. Okay, so in data set, you can incorporate count plot and pie plot both, or either count plot or pie plot. Okay, fine. So let me do one thing. Let me do one thing. Let me insert a table. In this table, here is a table. All right. What I will do, I will copy copy this image, Control C, and I will put it here, Control V here. Let's see. This is the distribution of tumor. This image, got it. And then I can pick up the pie chart also, Control C. Let me paste it here, Control V, distribution using pie plot. Okay, distribution using pie plot. Got it. And then let me double click on it, and after double clicking, I don't want any borders. Okay, I don't want any borders, so I can remove the borders also. I can remove the borders, no border. Now you can see both of my images are inserted in the research paper. So when you are talking about data set distribution, you can put up these two images also. It's not over yet. It's not over yet, sir. There is one more image in the implementation, this one, sir. Control C, let me copy this. Control C, and then put it here. Control V. So I am now having brain tumor images also. Here they are. Here they are. These are the images. Okay, these are the images for brain tumor. Okay, got it. I can adjust according to the requirement. Fine. It's up to me. We can adjust according to the requirement. Like this. Whatsoever. Okay, it's adjusting because of that. But you understood my concern. You understood my point, what I'm trying to say. So I got all these images from doc file. See, you should not be in a trouble that how to make the images, from where we are going to get the images. All reports are also available. See, let me show you the reports. I will let you know one more thing, which is very interesting. See, first of all, let me show you here. These plots are there. Accuracy plot, loss plot, confusion matrix. Okay, all the models which I have applied, their plots are available. Again, confusion matrix, it's there. Okay, got it. All this thing again. Every model which I have used, its confusion matrix image is there. Just you need to copy and paste. That's it. That's it. Got it. Now one more thing which will come in your mind, sir. Architectures are block diagrams, sir. But because in the methodology, now we need to put block diagrams also, sir. That has also been required. Okay, so how you make the block diagrams, sir? We make the block diagrams like for making a block diagram, draw, or either we need to insert, are there any shapes which are present, or we need to use a smart art, something block something. Okay, if you are interested in using some smart arts, and that's what you want to do, you can do. Okay, from your side, that means in the methodology, that what steps you have performed: data acquisition, pre-processing, then modeling. Okay, whatever your steps you have performed, that's okay. Apart from that, let me tell you one more thing. Let me tell you one more thing. If you struggle, if you struggle in making the block diagram of the model of the architecture which you have used, so do one thing. Well, this is the code. This is the code. Let me copy this code. Let me copy this code. Control C. Let me get to the GPT part. Here is Chat GPT. Okay, now utilize the concept of AI tool. In AI tool, okay, there is one website called as Figma. Kindly have a note of it. Figma. Okay, the Figma. This is an additional website. You can explore this additional website. Okay, from your side you can do. However, this Figma can also be incorporated with ChatGPT. So with ChatGPT, incorporate Figma. Okay, here this one, because people do ask to me, sir, how to make the block diagram of the architecture. Okay, so let me tell you. I'm incorporating Figma here with the ChatGPT. Now I will give a command. Kindly make a archi- architecture for this using Figma. I just put the code here. All right, I put a code here. I'm expecting the GPT to use Figma to create the block diagram or the architecture for my code. Okay, here it is now. Now this is Figma integrated. Now it will make the architecture. So whatever be the complex to the complex architecture, how the data, how a particular layer is working. See, See, this block diagram has been created by Figma. Let me click this part. Edit in Figma. Okay, edit in Figma. Let's edit in the Figma. Let's see. Okay, it will open. This is the simple CNN architecture. This is a simple CNN architecture. So what's happening? What's happening? Input MRI image, pre-processing, dataset loading given to the simple CNN model. Okay, training is given to the simple CNN. Then what is present in the architecture of simple CNN? Convolution block 1, convolution block 2, convolution 3, then flatten, then fully connected, then output layer, then predicted classes. Then loss function, back propagation. This is what happens in the training. This is what happens in the training. Okay, fine, got it. This is what happens. So entire architecture we have made using Figma. Now, if you're saying that, sir, this is a big architecture and will take a lot of space in the paper. Okay, though it's looking good. Okay, you can download the architectures also. File here, file, export as. So you can export them in PNG, JPG format, not an issue. You can export this architecture. But still, if you say no, this is a looking big one, so kindly mention here, no, we want only important 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 six blocks, six blocks. Also make it in vertical, not horizontal. You want only six major blocks which are used in the algorithm. Don't make horizontal, just make a vertical architecture. This is the command which you have given. All right, again the Figma will create for you. Okay, again the Figma is working, it will create. All right, here it is. Here it is. Let me edit on Figma. Okay, let me edit on Figma. Okay, here it is. Fine. And you can download. It's much more complex than I hope you have already seen that Figma can create, how it can create the architecture. I can download. Okay, file, export as PNG format, export. And let me show you the image here. Simple CNN architecture. This is how the image looks. This is how the image looks. All right, that's what you created. Don't mind, it will not come under plagiarism or something. Okay, this is how the image looks. We are not copying any image from any reference from any site, because if you copy any image, any architecture, something, so all right, that's a trouble. And it's always been asked from your side, kindly create the image from your side. Then again you will be trouble. Sir, it's taking lot of time to make a research paper. Image also we need to make from our side. All the blocks we need to make. Some blocks are going there, some blocks are going here. See, that's what we have created using a tool. Okay, input images plus pre-processing. See, you can customize this image from your instructions given to the chat gpt. You can do that. I just demonstrated a simple way. Then data loader, feature extraction, four convolution blocks with convolution, batch knowledge and relu pooling, classification head, training loss, evaluation accuracy. This is the architecture which you have used. Now, your time to speak. Any suggestions, any queries, any doubt, anything you like, anything you dislike, please let me know. Yes, please.
Sir, in AI generation, will it not be listed, sir?
AI generated image. That's what you are saying. That
No,
will
will
not.
it not be listed for plagiarism?
No, no, no. That will not create an issue. Ma'am, plagiarism is specifically related to what your text, especially. Okay, that will be related to your text. All right, fine. Not for this thing. Not for this thing. Images, we face trouble if we entirely copy paste any image from any sources, article, research papers like this. There we need to cite. There we need to cite. Okay, here I don't think so that you are going to face any trouble by such architecture, such image in form of an architecture. I don't think so you are going to have any issue. Okay, you should try. You should try and see. You should try and see. Okay, I don't think so you are going to be in trouble with this. You can edit the image. Yeah. We create templates, we create posters from different apps, isn't it? For this FDP also, we created a template or a poster from some app. We are going to input some record or profile. So is it going to be an obligatory? No, not at all. In fact, whatever be the images which has been created previously, they will be using some tools. So if they have been created by some tool, why to worry that okay, it should not be an AI tool? No, we use canvas templates which are already existing to create some architectures. So here is the architecture which we got. What's the issue? Use this architecture. Only just one thing you need to check, that whether the spellings and all are correct or not. But now they are getting smarter. They are not going to be incorrect. They are going to be correct only. And in case if you are interested, sir, these are looking very simple blocks. Okay, and one more thing I want to tell. You created actually with Figma. Remember, this is created by Figma, not by ChatGPT. Okay, don't have a misconception. This is created by a tool which creates architectures or the images. It's not AI generated. AI, you just only gave a prompt what to make, but it's created by Figma. Okay, madam. So don't. I think you got confused. It's AI generated image, so it will be great. No, it will not be. It's created by this tool. Okay, and everyone uses some tool to create it for good images. So keep this thing into a note that we can use Figma, and that's integrated with ChatGPT. Then more powerful. You can customize by just giving the prompts. Fine, got it. Okay, so in this way, once you have now learned uh, that. See what it is telling. IEEE journal figure style, PhD thesis architecture, PPT high contrast diagram. And right now, industry, organization, they are using the tools integrated, especially industry are all using. Now this AI tools are been integrated in form of AI agents. Okay, so we are not exactly using an AI tool, we are just commanding an AI tool. The work is done by Figma. Okay, so no need to worry about anything. And this is especially for building the architectures. Or rather, you can create a custom template here. Okay, you can create a custom template from your side. If you're not interested in this one, you can create, but that the result will be same only. Unnecessary, you will be wasting your time. Got it now. So like this is something a help for creating the architectures. Next, what I did, simple CNN I told you. Then I used Then I used models like VGG16, VGG19, Inception, Exception, all the models which I used. These are all pre-trained models. which I used over brain tumor dataset. These guys told that in the research paper that we are using DenseNet architecture, DenseNet 121. Okay, I also incorporated DenseNet 121 in my model, my architecture. Apart from that, I use other models also. And what I got, if I show you the scores, 98% with VGG 16, then 98% by VGG 19, then then 99% with Inception model. How much they claimed? How much these people claimed highest with DenseNet architecture? They claimed 96.90, and I am getting 99% on the same data set. I'm getting 99% with Inception V3. They are publishing the paper in a good journal named as Discover Oncology. Why should not I take a reference for this paper? I'm already in a better position. 99 with Inception, 98 with exception. Then with Densonet their own, I got 99. I got 99 with Densonet. That means I used far better approach on the same data set with the same algorithm. DenseNet and 99. Mobile net I'm getting 99. Okay, efficient net I'm getting 98. And here is the comparative plot. Yesterday also I took a workshop, same again. Workshop was faculty development program only. Okay, and see what's required. This is the comparative plot, comparison of various model accuracies, and I got this I got this in my code. It's available with me in form of an image. Here it is. Here it is. Comparison of model validation accuracy. Again, just copy and paste. That's it. Or either you want, okay, right click, save a picture as, save a picture as. You can save the pictures also in PNG format. So what I did a code with Python. I can display all the results. I can customize these plots also. And it's not in like you are going to create with a Figma only. With Python also, there is a command, there is an instruction that you can create the architectures. But that architecture will be not in a form of a like block or something. It will be huge architecture. We can display summary of an architecture also, model dot summary. It will show you the entire summary of what layers has been used there. But what is required to be present in the research paper, we are targeting that. So this image comparative, obviously the guide in our research papers, and obviously it will be in a requirement. It will be asked, kindly tell which model is highest. So Inception V3 98.58, round of 99, but 98.58 is the exact accuracy. It's proved to be the better. Then DenseNet came is 98.51. Okay, fine. This is the comparative plot. I used i used vision transformer also. They haven't talked in the entire literature review about transformers. But I used latest, like not latest, it's 2020 research paper, vision transformer. But I use vision transformer also, and these are the accuracy and the loss plots. This is the confusion matrix. I got 97% accuracy. This is what I achieved. Okay, and you are able to see I am getting all kind of plots. Now it's your matter. You have to ensure all the plots in your research paper, because as much as plots, as much as metric you are going to put it into the research paper, you will be in a safe hand, because if someone is interested only to see your research results, someone is going to see your research results only. More important, we want to see the result. Let's see what it is, whether it's good to publish or not. Results are important. Make more plots, include more plots, justify your metric, justify your outcomes. So what this research paper, what the authors did in their research, First of all, they explained about all the methodology, materials and methods, image acquisition. See, this is the architecture which made by the authors. This is what made by the authors. Now, similar, if you want to make, obviously you need to use your smart chart, smart arts or design. Okay, this one, draw or insert, smart art shapes. This is what you need to do. Either create by yourself manually. First, you can take a idea from the Figma that this is how the data flowing, this is how the blocks and the architectures built. Later, if you think from your side, you can insert the shapes and you can create your own architecture. Not an issue. Not an issue. Okay. I'm telling you one case Figma. There could be many other websites also. Just one I told you. Okay, got it. You can use smart arts, or rather you can use some shapes from your side. Okay, or rather you can use some available tools. Rest all images are available to me, available in my code. You can copy and paste. So what dataset explanation there, image is there, architecture. Now this architecture, DenseNet one-to-one architecture. How they have created this architecture? Because this is a complex architecture. How they are able to create this architecture? DenseNet one-to-one architecture. This is a tough architecture. They're not also putting any reference also that they have taken from somewhere. Obviously, some tools are required to create the architectures. Or might be they haven't put any reference, but this architecture should have been present. Copy image. Or what should I copy? Copy image. If I paste it here, if I paste it here, say, it's not in a paste thing. It's not. I think I need to search such DenseNet image. It's possible. Let me search. Let me search. Okay. Here, here. DenseNet one to one. DenseNet one to one images. Okay, DenseNet one to one images. Now there are so many images available for DenseNet one to one. Copying any of the image which is existing, that will comes under your plagiarism part. Okay, that will be under the plagiarism part. Now if you see, okay, this is the image available in the article. We are not going to copy paste exactly. That is not feasible. Here it is. There are images present, but not feasible to take them as directly. Okay, so many images are there. Research paper images are there, and what these guys did in the paper, what these guys did in the paper, whether they have drawn the image, is it possible how to draw these blocks? They might have used some tool. They might have used some tool. That is why I'm saying that use of that tool Figma will be easier for us to make complicated images. Okay, if I say to the Figma, it will create the image. It will create a block diagram for us. Easy to work, to interpret. AI generated image is different. And with a tool you create, that's different. So don't mix up. Okay, got it. Pre-processing, we are already done with the steps of pre-processing. Okay, here also again one more image came. Proposed layers for transfer learning. Though the image is not looking good quality one. It's not looking good quality image. We have to identify the tools which can help us, which can assist us in making good quality images. Anyways, it's published here. It's their own architecture, experimental setup, hyperparameters, what they have used, and there is a metric which they have applied: accuracy, precision, recall, F1 score, all these things. So it's quite clear that that in research methodology, you need to talk about the data set, you need to talk about the data pre-processing, you need to talk about the model architecture, you need to talk about model evaluation, you need to talk about the environment means what is the platform where you did the coding. Kindly mention that. Okay, I use Python, I used Python programming with Kaggle as a platform, or Colab as a platform, etc., where Jupyter node, whatever you have used. This much is the capacity, this much is the memory, this much is the processing capability, you have to tell. So environment should also be mentioned here. This is the research methodology which you have applied. It's a complete research methodology. Okay, got it. Architecture obviously should be built. Now, how to build? I've given you the idea. Either use your doc, design templates, smart art, etc., or you are going to use some external tool to make the block diagram. If you are copy pasting anything, cite it, and that is also subject to whether it will be accepted or not. After that, you will be proceeding ahead for result analysis discussion, result analysis future work, or let's say discussion. So, what they have discussed, result and discussion. So, performance analysis of proposed model. Well, well, see, classification accuracy, classification loss included. This plot I already got. This plot I already got from my code. Confusion matrix, this plot also I got from my code. All these plots are available. Just I need to save and paste it here. That's it. So training plots are there, confusion matrix plots are there with me. My work is so much quick can be done quickly, and I need to just explain the results which I have achieved, and see the kind of training. If I talk about, if I analyze the results, if I analyze from my side, this is training the validation accuracy loss for the proposed model, and this is for a densenet 1 to 1. If I talk about the analysis of the result, see, here we can have some fluctuations. Here losses are more, accuracy is less. Let me tell you one thing which I told yesterday also. Talking about the results, talking about the results, what is the expectation in the result? Well, if this is the training accuracy, this is the validation accuracy, it's an ideal condition. This is ideal condition. We expect validation accuracy should be more than training accuracy. This is ideal condition. However, it's not like mandatory we are going to face an ideal condition. It is subject to data. It is subject to pre-processing steps which you have applied. It is subject to the model you have used. So we don't have the ideal conditions expected every time. So you can suffer some fluctuations. This is training. This is how training is going. Training is going. This is how validation is going. Such kind of results you are getting. This is training. This is validation. Okay, piece of our fluctuation. Why these fluctuations happens? Because of data, data pre-processing. Is it correct or not? Have you normalized the data or not? Are you using techniques to prevent overfitting in the model or not? All these. There could be fluctuation. No, it's not smoothness. Okay, and you can see the results which are published by in this paper. DenseNet, training and validation accuracy by DenseNet 1 to 1. See, blue one is training accuracy, and orange one is validation accuracy. You can see these are closer to each other. Validation is less than the training. Okay, it means that if the training is 96, validation is 94. 2% gap between training and the validation. We can afford it. We can afford 2%, 3%, 4%, max. I am talking max. Now, which we cannot afford. If the training accuracy is 98%, validation accuracy is 90%, we are not going to afford it. Your model is showing overfitting. And this can be exactly seen by the diagram, by the picture, that training accuracy is this, validation accuracy is this. If you can see the gap between training and the validation, it's not good. Okay, it's not good. That means it's showing overfitting in the model. Okay, got it. This should be close to each other. And if the validation is greater than the training, then best, you have done the best work. Okay, got it. So by seeing these results only, we can find no need to read anything. Got clear idea. All right, confusion matrix is also telling. All right, they have explained the entire results. AUC, ROC curve, area under curve and receiver operating characteristics. If there's a binary classification, we can apply AUC, ROC. Okay, these plots are also so every plot has been explained in detail by the author. Every plot, what we have achieved, every plot, and this is the gradcam results. These are the gradcam results. That is called as explainable AI. One more thing I want to tell you. One more thing I want to tell you. Right now, the publishers are expecting that your model should be explainable in nature. Explainable. Explainable AI. So, if possible, we introduce explainable AI results. That means what made model to conclude that this is tumor and this is no tumor. What made a model to tell which why it's tumor, why it's not a tumor, or why this is benign, why this is malignant, why this is no tumor, why this is any other kind of class. So explainable AI. And images we use gradcam plus plus. These are used in images. Okay, and you can see in the results. These are gradcam results. Okay. Inception V3 identified that here is a tumor efficient this region, DenseNet this region. So with CNN based architectures, gradcam is used. That is called as gradient activation map. They are used. Okay, and then obviously you need to use this precision recall, this comparative table. Okay, these gradcam results also you need to incorporate. Explainable AI. To justify your model, you have to use this results also. Then only the paper will be published. Now, however, paper will be published unless and until you don't have the quality plots, unless and until you don't have the good scores coming, unless and until like the justification is not available. Okay, how the paper will be published? All detailed explanation of the results has been given. It's a lengthy paper. Okay, performance comparison, everything, and with the existing models also. Comparison with existing models also done at the end. They told a proposed method got 96.90%. I can make a paper from my side. and I can beat this person. He's showing 96.90. I've shown you 99 also. Okay, one paper will be ready in a quick mode from our side. They have done all the tasks, literature, everything they have done. I will add five literature from my side. I will take their own literatures. In fact, the paper itself I will take as one of the literature as my base paper. I'll take it as a base paper. They have used DenseNet one to one. Okay, I'll use other models including DenseNet one to one. I shown you and compare the results. Okay, got it. Fine. So here is a comparison. Then they are writing the conclusion. Conclusion that early brain tumor detection is important. Different approaches were used, and localization is very much difficult. So in this study, we used DisNet, and we got this is a score. Okay, and we are suggesting for the next we can apply for segmentation also. We'll apply any other data set also. That's it. Over. Done. Paper is over. Paper is over. So coding done, implementation done, all results I got from here. Literature review I told, how to make a block diagram, how to make an architecture that I told. Okay, how to initiate this thing I told. Everything. Now any doubt please let me know. Then we'll take the another data set which is not the image data set but that will be Excel file data set. Yes, any doubt please let me know. Yes, anything you want to.
Sir,
Yes, please, madam.
they have told 96 and you're getting 99. How is that difference, sir?
96 and
We have
99.
taken the
Hmm. Hmm.
we have taken the same pre-processing everything, or you have changed something, sir?
No, madam, I
Or
have
will it
taken the
keep on
same data set,
changing?
madam. I have taken the same data
Okay.
set.
Pre-processing also same thing, sir.
Pre-processing. The only thing is pre-processing step, which marked a better pre-processing. I have taken the steps which I will mention in the pre-processing. If you check, here is the
Mm-hmm.
pre-processing part. All right. In pre-processing, what I am doing, I am applying the transformations. Let's say 224, 224. I am resizing the image. I am doing the horizontal flip. Okay, I am converting the image into tensor. That means high dimensional data. Okay, high dimensional representation of the data. Much more. Tensor is high dimensional representation of the data. We want to normalize the image between 0 to 1. That's what they have also did. We have also did. Same thing we like that's the required transformations we have did. Images are already of good quality, so we are not applying any other technique extra from our side to enhance the quality of the image. That's not required. Okay, already good quality images are mentioned. Only the thing is we converted the image into RGB. They also converted the image into RGB. The reason is these are pre-trained models. So either DenseNet, either ResNet, either this and that all use colored images. They also did, I
Okay.
also did. So this is the pre-processing part, madam, which is mentioned here.
Okay.
Here.
In the review, sir,
Hmm.
like one of the paper, I got a accuracy of 99.6 or something.
99.6. Okay.
Uh, yeah.
Huh.
For that, I got a review saying that this is not a valid
Okay.
or a acceptable
Okay.
image.
I understood,
How
madam.
to
What they
answer
are
such
telling is,
question?
what they told us that no, AI models are no, that getting 99% accuracy is not a valid idea. It's not a good idea. Kindly show the accuracy is 98 something or 97 something or 96 point something. 99 accuracy is not a good idea. That's what you got the review. Am I right, madam?
Yes, sir. The review was that. I didn't know how to answer that also, sir.
Mhm.
Like,
Okay.
what is
Okay.
the way in which I can.
All right, all right. How to answer this question? Okay, justify. Now that's what I told. Justify your answer. Justify your results. That should be very much important. Justification.
So
Yes.
that is after the review when you get how to go about it.
So how to reply that, madam? You published. You published. That means the plots were there. All the plots were there.
Yeah.
Training plots are
Everything
there,
was there.
validation plot is there, for accuracy, for losses,
Yeah,
confusion
yeah.
between
Whatever you showed, everything was incorporated.
okay, everything is
But one of the reviewer among around six, seven reviewers,
huh?
one reviewer told it is not a justifiable result. I
Okay, okay.
mean, what?
Does it
I
showing
mean, how could?
overfitting, madam?
Overfitting wasn't there, sir.
Isn't there? If your score is 99, your training score, obviously overfitting, I also don't believe that overfitting will be there, because you already got 99 and that should be over test data. So training will also be nearly 99 only. Okay, what's the size of your data? Size of your data, how many images were there, madam? Or how many
It was around
reports are-
7,000 change.
Yes, madam.
7,000 change. 7,000 change was there.
Okay, 7,000 images were there. Okay, nearly
Yeah, yeah.
7,000.
But Boosie data I was Boosie data for breast cancer was just
Okay,
tracking
breast
that.
cancer data was there. Breast cancer data. Okay, have you applied, madam,
Uh-huh.
augmentation? Augmentation, how many types of
Yeah,
augmentation?
augmentation,
Horizontal,
augmentation with all the horizontal flipping, everything I did, sir.
rotation.
And the
Uh,
problem is, once we write the paper and give it to the publisher, it nearly takes 6 months to publish.
uh,
So by then, probably would have all forgotten what we have done.
okay, okay. So, madam, I just
That's why,
want to
yeah.
convey, in case images 7,000, images are 7,000. So, ma'am, number of images should also be more. Okay. That's what we expect, that number of images should also be more, and augmentation should be more tight than it case, that's the case, like rotation, if you did 2 degree or 5 degree, okay, make
Hmm.
much more diversity in the model, so it will not show 99 in that case, that will be a bit
Okay.
reduced. Okay, much more
No,
diversity.
as per you, getting 99 is not a proper accuracy.
No, I'm
Then
not
probably we
denying.
may have
I'm not denying. No,
do
no, no,
better.
I'm not denying, madam. That's not a proper accuracy. I'm not at all denying that. I have seen the papers where people got 99%, madam, 99.67% accuracy. I've seen the paper.
Yeah, yeah, yeah.
Okay, so it's a matter of the fact what the reviewer thought based upon the data, based upon the
Okay,
technique used. The
okay.
reviewer thought.
No, that's what I didn't change anything, sir. I didn't change anything. I just kept quiet with that review.
Hmm,
And the paper.
hmm. Am I audible? Am I audible? Am I audible to everyone?
Yes, sir. Yes, sir.
Okay, okay. So actually, yeah, there was one issue. Yes, ma'am. You were telling something. What happened with the reviewer, ma'am?
That's what, sir. I never bothered.
Okay, okay.
It was a long
Right.
time.
Uh-huh.
Only one reviewer commented on that. So
Mhm.
I didn't, I mean, it didn't affect much.
Okay. So, ma'am, what happens now? Such kind of review can come and subject to the data, subject to the algorithm used, subject to the technique used. They can say no, 99% is not been enough. So, whatever we obtained, we are putting as a result in front of them. None of our technique applied is wrong. We
Yeah.
got it based upon what we did. Okay, whether it's 90,
So we can keep quiet. We have done the work.
we done the work and we got it over that particular data set. In AI, madam, in AI, this is what happens, that 100% accuracy is not correct. We are not showing any 100% accuracy. Okay, ye to, it's not possible. 100% not possible. Okay, if you are getting 99.67, let's say this much percent of accuracy over a particular data set. All right. So in that particular case, we can say that over this much number of images, 7,000 number of images, we split it the data into 5,000, we split it the data into 2,000, we applied the augmentation and all the pre-processing steps over the data set, and this is what we have achieved over the test data. All right. And also check, madam, whether the issue which I mentioned previously, the balancing, is that proper balanced or not? First thing.
Okay.
Second, madam, is there any data exposure from test to the training it happened or not? Okay. So if your pre-processing was correct, if it is pre-processing correct, then your model is strong and it's able to capture hidden patterns in the data. The question was
Okay.
raised because of this thing only. 99, the person was thinking how? How?
Hmm.
So, madam, please refer to the pre-processing properly and make it tight. Horizontal flip you did, vertical flip. Rotation 5 degree. Contrast, zoom, apply.
Hmm.
Okay. And then we'll see how the
Okay.
results are coming.
Yes.
And also, madam, there are some statistical or not say in status we are having hypothesis testing. Okay,
Yeah. Yeah.
so
Hypothesis.
in order to justify, we can incorporate some hypothesis also.
Okay.
Okay, we do have ablation studies also. Ablation studies.
Yeah, I did ablation study and cross validation also, sir.
Mm-hmm. Okay, cross validation you did, madam.
Okay. Yeah, yeah.
All right, fine. That means you have changed the parameters and then tested. Still, the accuracy was good,
Yeah.
madam.
Yeah, it was good, sir. That's why in long back I
All
did
right. That means
around
with the
six, seven
existing
years.
data you applied, but now please refer to the pre-processing.
Okay, okay. Probably there I have
Ah,
missed
yes,
something, sir.
madam. Is there any data exposure happening? That's why the model reached to 99.
Okay. Sir,
Okay.
in one of the classes, if you take up hypothesis testing also, it will be okay, sir.
Ah, yes, ma'am. I look for hypothesis testing also. Okay. And I think in
Okay.
our, because ma'am, okay, let's consider ma'am another project. Let's consider another project.
Okay.
Apart from this images, ma'am, I do have a data set. I do have a data set. I hope you can see the data set. This data set is for multi-disease prediction. Ma'am, you asked for previously that apart from images, take some kind of data set which is in a tabular format. Okay.
Yeah.
So this is the data set of multi-disease. Okay, where I do have glucose, cholesterol, hemoglobin platelets, WBC, RBC, and all the medical parameters present in it. All the medical parameters present in it. And my target column is disease, healthy, diabetes, etc. etc. It's multi-disease problem actually, not single, multiple disease problem.
So data set in CAD is good?
Data set is available. Kaggle ma'am, I will share this data set along with the code also. I will share.
Yes. Yes.
All right. And I think papers are also being published on multi-disease classification. There are papers in good journals also. Papers are there for multi-disease classification. All right. I'll share the paper also. Fine. So we got this data set. We got this problem statement, and it's a classification problem. Obviously, that I need to classify whether person is healthy or diabetic or anemia or etc. etc. Okay. So the problem statement is multi-disease classification. So it's a classification problem. What kind of data available to us? A record, tabular format. Okay. Now we have to build algorithm for it. We have to build algorithm for it. We need to write research for it. That is what we need to do. So again, we will start by collecting the papers for multiple disease prediction, what algorithm previous authors did. And obviously, we are going to get machine learning, deep learning algorithms, especially machine learning algorithms like logistic regression, support vector machine, decision tree, random forest, XGBoost, All these algorithms we are going to get from the deep learning, we are going to get some neural network. This is what we are going to get. Okay, fine. The point is you are having a tabular data. Okay. Now analysis of tabular data is also important. How to make a methodology on tabular data, that is also important. And now we have already learned that how to make the abstract part, that will be later. First of all will be the introduction. Okay, and or first of all, starting of the research, what I think is, okay, you are available with the topic. That means problem statement is there. Second, is there a data set? Selecting research topic depends upon the data set. Remember, I never suggest anyone that select a topic. Okay, sir, we like this topic, that topic. I said, okay, okay. You like the topic? Okay, fine. Is there data set available? Is there data set available? Then it's a challenge. If data set is available, then I damn sure tell you go ahead for any kind of topic if data set is available. Because I never mind of building any algorithm or any technique, but I mind if the data set is not available and you are looking forward for topic. No. Before selecting any topic, check the data. Is it there or not? If data is there, then we'll proceed ahead. So data is there, topic selected, classification. Fine. Classification is there. Fine. You need to do. What kind of data set? Sir, tabular data set is there. Okay, got it. We did literatures. We collected the papers. And from the papers, we identified that on this data set, the accuracy is again same like 97, 98 something, the accuracy is there. Okay, fine. Algorithms, what they have used, these algorithms they have used. Okay, fine. We write the literature review. I think we had a discussion of literature review today. We'll write it in that way. That's something simple from my end. Now, working on this data set, let me show you how do I work on this data set. And first of all, you can see so many records are available. So many records are available. All numbers and all these things are available in the data set. Okay, all these things are available in the data set. So, which features will be important for us? Which features will be not important for us? Well, let me clear you from the starting that what should be in your mind to start working on code or project or implementation in your data set. If it is tabular, then our expectation should be that there must be numerical records more. There should be more numerical columns in the data set, mandatory. And in numerical also continuous features should be there more. Then only the good analysis will be done. Then only good analysis will be done, because continuous, this represent the actual statistics, and our models are based upon statistics. Okay, therefore I always request in your data set numerical features should be more, and in numerical continuous should be more. Then it will be a good approach to work upon. If we have categorical columns more, then only thing to convert categorical into 0 and 1. If you are having discrete columns, they are already in 0 and 1. So what to do with 0 and 1? We expect continuous columns more. And by seeing in this data set, you can check hemoglobin continuous in nature, platelets continuous in nature, WBC continuous in nature, RBC continuous in nature. So most of the features are continuous in nature. This is one of the good data set to work upon. Your target is disease that is categorical in nature. I can convert it into some labels that will do in the coding part. But most of the columns here are continuous in nature. That's a good thing to work upon. And here is the code for it. Here is the code for it. Here is the code. Multi-disease classification code. Multi-disease prediction using machine learning. Here is the code. So first I will take the basic libraries. Let me run in front of you also. First I'm going to take the basic libraries. NumPy, Pandas and all these are the basic libraries I'm going to pick up for it. Okay. Then I'm going to pick up the data set, create a data frame, multi-disease prediction. That's what I'm going to take. The code is under execution. Let it get finished. Okay, done. So this is my data frame, DF. First five rows of the data frame, the data is as I have shown to you. Okay, this is the data. Glucose, cholesterol, hemoglobin, platelets, and all these things. Last one is the disease that is our target. That's what we want to achieve. Okay, head, then tail. Okay, shape. Okay, we are having 2351 rows and 25 columns in our data set. That's the data set. These are the column names. These are the column names. We do have this much duplicates present in our data set. The issue is we are having 2351 rows, and out of 2351 rows, 2286 are the duplicates. Okay, we will just keep it. We're not going to drop the duplicates. In general, we drop it. If I drop the duplicate, then there is nothing left in my data set. Only 100 records will be there, and we are not going to do anything on 100 records. Okay, fine. That's what we are not going to do. So duplicates identified, that yes, there are duplicates present in the data set, but let it be. Keep it. All right, fine. Then null values, no null values present in the data set. DF info, information of each and every column in the data set. DF describe, statistical description of every column in the data set. DF n unique, every unique value present in the data set, number of unique values present in the data set. So it's 65 in each and every column, unique values. There are five kind of disease which are present in the data set. Okay. So if I need to write the methodology has always been the same. No? Whether you are working on images, whether you are working on text, whether you are working on such kind of record. So methodology require first data acquisition. So we'll say that we collected the data from this and this source. It comprises of this much number of columns, and our target column was disease, and there are five kinds of disease, and we will be showing the count plot and a pie plot for it. That's what we are going to do. This is data acquisition. Source, and what present in it, show count plot and pie plot for only disease. Okay, and it will be like this much is this much is for you can consider any of the disease like diabetes, anemia, like any of them. Diabetes this much, anemia this much, healthy this much, like this is count plot. They show the pie plot also the distribution as I shown there. This is data acquisition. Second, data pre-processing. What we are going to do in the data pre-processing, sir? This record is not image record. So what's we are going to do in the pre-processing? Yes, yes, madam, please. Yes, any doubt, please, madam. If you want
Sir, mistake, sir. It's by mistake.
by mistake. Okay, okay, all right, by mistake. Okay, so you are having this record, and what pre-processing you are going to apply with this record? I was actually doing that thing only. I was looking forward for duplicates, I was looking forward for null values. Then, then since most of my columns are continuous in nature, if I got duplicate, I need to do something. If I got null value, I need to fill them. Then my data set is having continuous values more. I will make the histogram for them or plot for them, distribution plot for them. My expectation again is like this. This is my expectation. But once you make for continuous, you may get this, you may get this. That means skewed. Skewed plots you are going to get it. Okay. Skewed plots you are going to get it. Well, well, this is classification problem. Classification problem. If it would have been regression problem, then there is a demand from a model like linear regression that we accept the features to be normally distributed. That is what our expectation. This is what it expects. If regression was there, okay. Currently, you are dealing with classification problem. Still, we are not going to follow some skewed plots. We will try to identify outliers. We will remove the outliers. I hope you are aware of the outliers. That means faulty entries present in the data set. For that, we make box plots. Box plots. Let me show you the code. I did the entire analysis. Let me show you. These are the counter plot for my disease, healthy, and all these counter plot. This is the pie plot, and this pie plot which you are seeing is made by a library Plotly in Python. That is very highly interactive library in Python. Apart from Matplotlib or Cbon, which are the basic libraries, you can use Plotly as one of the highly interactive library. And whatever with the plots I'm getting, you can download here as a PNG file and you can put it in your research paper. If you think that this image is good, it's colorful, it's interactive, okay, you can download it. Download and put it in your research paper. Not an issue. All right, got it. So pie plot and all rest of the plot. See here how the distribution of how the distribution of each and every feature is there. This is the distribution of each and every feature. And by looking these, it's not at all. It's not exactly the normal distribution. No, it's unusual distribution. Okay, it's unusual distribution. What I made? I made a histogram. For continuous, we make histogram only. Okay, so histoplot, distoplot, this is distribution plot like histogram only. This is distoplot. We do have KD plots also. Okay, it looks like similar only. KD. This is line. Na? This one which you're seeing. This is kernel density estimation. KD. Showing the density that between this interval to this interval, how much values are coming. Just about density. Anyways, this is box plot which will let you know the outliers present in the data. These are the box plots. So outliers are the wrong or faulty entries, and that will be present either here or either here. Some dots, some points that will be shown here or either here. Now it's up to you what kind of plots you want to incorporate in your research paper. It's your choice of interest. Which are informative in nature, you can do that. Okay, ignore this one. This boxon is not required. Okay, ignore these plots. Okay, these plots will be ignored. So after making this basic plots, after making these basic plots, what we do, what we check in our pre-processing part or some important steps, we remove the outliers. Okay, we done. We check correlation between the features. We check correlation between the features. Well, the expectation is feature should be have a good relation with the target, but feature should not have a good relation with its corresponding feature. No, because this will result in overfitting of the model. So with target, if the feature is good related, fine, we are happy. But among each other, if they are related, no, we are not happy. So we need to check the correlation between the features. There is a Python df.corr. This is the command. You can get the correlation. df.corr will identify the correlation between the features. There are two kinds of correlation: positive, negative. If with F1, F2 is increasing, F1 is increasing, F2 is increasing, or if it is decreasing, this is also decreasing, positive correlation. Now, if F1 is increasing, F2 is decreasing, negative correlation. That means inverse. See, any kind of correlation is there, we are going to treat it. We are not going to keep the features which are correlated to each other or highly correlated to each other. So first of all, we need to identify how features are related with the target. And if you are having so many features present in your data set, currently we are having, let's say, at least 24 or something features are there. This much number of features are there. So kindly identify top 10 features which are good in, or top 15 features, let's say. Top 15 features which are good in a relation with the target. This is what you need to identify. Top 15. Out of this top 15, now identify that which among them are correlated to each other high, because I need to drop. I need to drop. Now let's say how to drop. How to drop. We are having feature F1, we are having feature F2. They both are in a good relation with the target, but they are also correlated to each other. But we need to check. F1 is 90% related to the target, F2 is 80% related to the target. And both of them are also correspondingly related to each other. So if I need to drop anything, I will be dropping F2. Why? Because F1 is 90% related to the target, I will keep it, and I will drop F2. One more thing I want to say: dropping any feature from the data is a loss, obviously, because you're dropping something, it's a loss, no? Loss of information. Loss of information. Dropping anything from the data is a loss. But keeping all the things for training a model is also a loss. Model is overfitting, because there is a problem that is called as curse of dimensionality. There is a problem in machine learning models, overfitting. That's one of the thing, and that's because of curse of dimensionality. If we keep as many as features present in our model for the training, which are correlated to each other, then it's called as curse of dimensionality. It will result in overfitting. So only we need to select top 10 features out of 24 features which are good related to the target and which are least related among each other. So make a new data frame, let's say df1, which are having all these 10 features present along with the target. So now 11 features are there, top 10 are we are available with, which are good with the target. We'll work on these only, not all. Then you need to further pre-process the data. For that, you need to scale the data or you need to normalize the data. There are different kinds of scaling: standard scaler, min max scaler, robust scaler. There are so many scaling techniques. Standard scaler formula is x minus nu upon sigma. Here you can scale a feature by putting its value by taking the mean of the entire column divided by standard deviation. Okay, you don't have to do the formula. It's already available in the function. You don't have to do anything. It's there. Standard scaler scale the values like let's say between minus 1 to plus 1. We do have negative values also present here in standard scaler. While in min max scaler, we scale a particular value between 0 to 1. Mostly preferred is standard scaler, mostly used, mostly. We use this scaling. And that is also mandatory to scale. Mandatory to scale. Because in a data set, let's say this is feature F1, this is feature F2, F3 target. If feature F1 is having a values 10,000, 20,000, 30,000. Feature F2 is having value 10, 12, 13, like that. There is one thing dominant in data set in statistics, that's what we say. Any feature which is having high value or any feature whose distribution is more, its variance is more, and any feature whose variance is more, it's contributing more in model development. Now, if this feature whose distribution is more, its variance is more, it's contributing more in the development, what will happen with this feature? The point is clear. This feature is rich, this feature is poor, and we know that what will happen in the world if someone is poor. The poor will be dominated by the rich. So our expectation was equal contribution for all the features in model development, but this one was rich. So it contributed more in the model development, and this person was poor person, so nothing happened. That is why we do scaling. That is why we standardize the data. Standardization. That is why it's required to standardize the data. And that's one of the step of pre-processing. Important step. Yes, any doubt, please let me know. Do you want to say any point, any suggestion, like anything you want to say, you can. In the upcoming class, I'm going to like wind up this thing also. Then, ma'am, as you said about cross validation techniques, some hypothesis testing, that also I try to incorporate here in this particular code. Okay, then we'll talk about the overleaf paper building too. Okay, all these things I will incorporate in the next classes. Overleaf, how we can take the content, and then what suggestions come in the overleaf, and then we'll check, we'll improve according to the overleaf. Whatever be the important things for the research perspective, I will incorporate it in the next two sessions. Is anything, any questions, any queries you want to say? Any query?
Next class, you will explain us about the further of the problems. Sir.
Yes, ma'am.
Next, I mean, next class, we will be taking up this problem again.
Ah, yes, ma'am. This problem will continue. Okay, as per the research
Yes.
perspective, I will incorporate, ma'am, as you
Okay.
told about cross validation, some statistical, some hypothesis testing, ablation study. According to that, I will incorporate. Okay, and then, ma'am, related to overleaf paper development. Okay, what are the
Yes, sir.
important
Yes.
elements for building a research paper? We'll check with overleaf.
Yes. Yes.
All right, all right. So this is
I think no
complex.
questions.